Believe it or not, Java 9 has been released. Believe it or not, if you install Eclipse Oxygen.1a, you get one version of JDT that allows you to develop Java 9 applications. Wow. It has been a slightly bumpy road if you have followed the news, initially on the side of Java 9 and transitively also for Eclipse, of course. Instead of indulging in excuses and promises what will be better in the future, I would like to invite you to just enter the lab, the workshop where all this has been implemented in JDT. Just join us for some insider's view, and I want to share with you just a few things that I learned about Java 9 just by implementing compilers and corresponding support for this. And I will present this story as an act in 4 plays. No, a play for act. In Act 1, we will very naively approach this and ask ourselves, do we know what Jigsaw is all about? And as a disclaimer, Jigsaw is all this talk is about, really. I'm not covering other topics of Java 9, but this being the biggest one. And in Act 1, I want to show it in a way that you really understand this is simple and really, really easy. Why can I say so? I mean, everybody who's able to write an OSGI manifest, as you see it on the right-hand side, plus maybe a little bit of declarative services, but just by learning a slightly different syntax, as you see on the left-hand side, can immediately write modules in Java 9. Because module minus info.java is a strict subset of what you see on the right-hand side. So I'm not even explaining the direct correspondence, just a new syntax for something we've been doing for years. So instead of speaking a lot about this, let us just look at one example where I have some fake projects in my Eclipse workspace. They have been developed as Java 8 programs. I already changed the compliance to Java 9, and now I want to turn this into a modular application. So what I do, it's simulating a 3-tier architecture, so I should start at the bottom. The server project, I just select configure and create module minus info.java, and it analyzes the project, suggests a name for the module, and all that you see is a new file, module demo server. It exports a few packages, maybe the impl we don't want to export, so it just suggests everything that's there. And we can continue to the next level where it claims to contain the application logic, create module minus info.java, suggests the module name, and again, all the exports, and it also recognizes that this module depends on the other module that I've created before, so it creates the require statement. All is nice, and if I just continue this on the last level, I should have a fully modular application. All looks fine, so let's just look at the main class in here and just run it as a Java application. And well, it could be very easy. I'm not going into resolving this thing. Here, I'm using some services which have not been wired up correctly in module minus info. So we're not analyzing that deeply. Yeah, the first encounter is very simple and easy, and there will be gotchas. This concludes Act 1 already, and in Act 2, we will get a little closer to this new file, module minus info, and I will totally switch sides now and not show anything of how it works in the UI, but what does it mean for people developing the tools for this? And the first thing, if we look at module minus info.java, so we have some API in JDT where I highlighted here a class called a type called iScanner. Thinking about compiler technology, who in this room, raise your hands please, if you're comfortable with the distinction. There's something that's called a scanner or tokenizer or something, lexer, and then there's a second component that is called a parser. Who's familiar with this distinction? Great for you, forget it. This distinction is no longer useful for Java 9. And this API that I've shown you is impossible to correctly implement in the way you would expect it to work for Java 9. So how did they succeed to break such a fundamental concept in compiler technology? A scanner is the simplest thing that we could think of here. How did they succeed to do that? They invented a concept that they call restricted keywords. And the first 10 times I read the specification, I didn't really see anything suspicious in there. It looks just fine. And only at the 10th or the 11th time, I really realized what they really mean. They gave some explanation, and then I understood what they mean is that these are keywords that are keywords when they're keywords. Otherwise, they're identifiers. And the bad thing about this, from an implementation point of view, the point in time when you know the difference, the point in time when you know for sure if a word is a keyword or identifier is after parsing. Then you can produce the input to the parser after parsing. So the good news is it allows you to write things like this. Let's show it in the IDE so you really believe me. This is a real file and it compiles and it's error-free. So this is the name of the module. It's called module. And it requires another module, and that module is called requires. And so this is a package. This is an interface. This is a class. Sure? Okay. There may be reasons for this, and I should be honest. Of course, if you introduce new keywords in Java, we have to be very careful because those new words will already be in use in some programs. So that's the background behind this. But everybody who's doing cross-language working with different languages referring to each other knows. So just yesterday I learned that Scala, for example, allows you to just backtick a keyword and it's no longer a keyword. And everybody who's working with a language that is somehow connected to Xtext knows there's a very simple solution to this problem, and in Xtext and other language they use this token. Put it before a keyword and it's no longer a keyword, and so you can refer to it as a name. As I was pretty scared about the new change, I proposed this exact solution to the expert group with no success. So where does it leave us? We have an API. The API is no longer able to do what it claims to do. And to tell the truth, we haven't decided for this particular API yet. So one thing is we should probably just remove it because it no longer works. But that potentially means that every plugin out there that sits on top of JDT would be broken because they probably don't expect a JDT 4 point something. This would be very big impact on all the adopters of JDT. So we didn't like to go that way. Currently, we are trying kind of to think of, well, probably nobody would have the idea to use a scanner for module-info.java. Maybe they just don't do that. My current thinking is that we should probably, so this should strike the token name identifier. Sorry for misalignment. If the scanner answers this is an identifier, this answer may be wrong. So if we just deprecate this one constant, this may allow plugin writers in the correct sense. But looking behind, the underlying question is actually, is module-info.java really a Java file? I don't have an answer. I just have another question. Is if we compile that to .class, is module-info.class a real class file? Let's have a look at it from the toolsmith's perspective. We have API. There's a type iClass file in JDT. And it has lots of methods. One of them is getType, and we have a promise this method will never return null unless the class file is module-info.class. It doesn't contain a type, of course. Normally, it would be a format error, and you would get an exception. But now, it is illegal to have not a type, but a class file. So here, we already deprecated this method. And in order to help adapters to accommodate this change, we had to introduce two new sub-interfaces. So if you do an instance of check and you discover this is an ordinary class file, the old API still works. But if you discover it's a modular class file, then it contains a module, not a type. Straightforward. Speaking about damaged API, one last example, no longer relating to module minus info.java or class, but to something that we call a class path container. If you don't use this concept, don't worry, things working pretty well. But if you do, you may be interested to learn about the following change. In a nutshell, these containers are the things that represent in JDT things like a JRE system library or plugin dependencies or Maven dependencies, these containers. And we have a contract that you can resolve them and get the individual class path entries, and from those you get either libraries or jars. So this is what it looks like for JRE 1.8. It contains all the jar files, and inside the jar files you can go to the package fragment roots, and then to the packages, and then to the class files, and then down the types. Format changed. JRE system library looks completely different in Java 9, and there's no longer jars in there. And so this line of the contract that everything you get from here is either a library or jar is broken. A project or a jar, sorry. No, library being a jar or a project, yeah. In Java 9, it now looks like this, and this is a little bit of a fake currently. You can still expand the node and see a lot of details, but now the details are modules, not jars, and everything you see to the right-hand side ending with JRT minus FS, that's a fake. That's the only jar we could find, but it's not the content, but the API we use for reading this stuff. So that's cheating, actually. But the good news for most plugin developers is that down the line, if you still do the normal thing to get those class path entries and then ask the project to resolve them to package fragment roots, etc., it still works. Just the thing in the middle is fake, and we will probably change this for the 0.2 release, but just haven't decided which way to fix this. So end of Act 2, and we've seen, things are a little bit weird. Some changes are disruptive for tool implementers. In Act 3, we will get entangled in a little bit of complexity. And still, again, I'm starting with some very simple questions. So the focus of all this will be qualified names. What's the meaning of a name A.B.C1? Is it legal to use that name in your program? And maybe you heard rumors that Java 9 does away with split packages. Is it true or is it false? If the story would continue in the style of Act 1, this would be all I had to show you. And this is initially how I understood the entire module system. Modules contain packages. Some packages are visible from the outside, others are purely internal. Packages contain classes, some are private, some other are public, and just with one new relationship between packages called requires, you can immediately figure out which part of the code can read which other part of the code. When developing JDT, our job is to handle corner cases. And to figure out the semantics of corner cases, this picture is not enough. In order to figure that out, we have to look at a JLS. And the Java language specification describes this situation slightly different. This is a simplified version. The previous version is more comprehensive than this one. And the first surprise is packages are not contained in modules. Packages live in their own universe, still continue to live in their own universe. Classes are not contained in packages. The one thing that comes into focus if you want to understand all this in terms of JLS is something you didn't see before, compilation units. Plain English, files. So a compilation unit is a thing that is associated to a module. A compilation unit is a thing that declares a package. Package doesn't exist before the compilation unit declares it. And yeah, so if we contrast these two representations, we can see how with these three new relationships involving compilation units, we kind of emulate the containment that would make explanation so easy. By contrast, we see a new containment relationship on the right-hand side, which is quite funny, and it has been there all the time, so that's nothing newly introduced by Java 9. There's a containment relationship between packages. Why am I mentioning this? This relationship is of no semantic significance. So just forget about it. Packages have a name that happens to contain dots. And you don't need to know anything more about packages, and in particular there's no relationship between them to really understand the semantics of Java. But the specification starts with explaining how a package is a member of another package, and that may be a member of another packages. And this actually contributes a lot to the complexity of the specification for no obvious benefit, as far as I can see. So let's put this view of the world to work to really look at some of the corner cases to learn how much of isolation we maybe get, and what's encapsulation in Jigsaw really at the bare metal. So what's the meaning of a qualified name ab.c1 when looking from module 2? So this is new. You always have to specify the perspective where you're starting to look from. And it's easy to see that there is a type called C1 in a compilation unit that declares a package a.b, and this is associated to module 2. And so in module 2, you can interpret this name as the one class C1. You can see, let's try pointing. You find it. So this is a good case. And the new rule that's the center of the new specification here also requires that the package AB must be uniquely visible to the module and module 2. I'll show you what this means by a counterexample. Well, I just add one more edge to this diagram, an export edge, so that module 1 now exports package AB. This violates the rule, so now there is two paths in this diagram how from module 1 you can reach package AB. And this is enough to declare that this is an illegal program. The package AB is no longer uniquely visible, so this is illegal. And I mean, in this case, it would actually cause a name clash, but even if we change one of those compilation units from CU1 to X and the class change to X, there's no name clash at the class level, but at the package level, still the application is illegal. There is some sense behind this because package level access across module boundaries may be a little non-obvious, a little dangerous. So that's the rule. Not or uniquely visible is what makes a difference. Let's remove the edge. So this is a legal program. We can execute it, right? So just I omitted some module path command line options, and we can wait. Compiler told me this is a legal program. JVM says no, I don't like that program, and the error message we get is package AB in both module 1 and module 2. Even if I don't have any location that requests to look at both of them. So isolation is broken. The hint, what's going on here is in the name of the exception. Java lang layer instantiation exception. What the heck is a layer? So this is something you need to know if you want to use this style of programming. JVM doesn't provide a mechanism to handle this at runtime, but you are allowed to implement a layer, some kind of container, and if that layer happens to use some class loader-based isolation, then you will be able to run that program. Okay, let's aggravate the situation just slightly and add a method to one of the exported classes from module 1. In this class C2, I add a method that has in its signature a type reference a.b.c1. We've seen that name before. But now, looking from this module, obviously it refers to the other type of the same name, which is also in package a.b, because this is the one that can be seen from module 1. Okay, possible. What happens if some guy inside module 2 invokes that method? I don't think this is a good program, right? Because that client has not really a chance, it has, but no obvious chance to really make sense of this method. So this is what I call an API leak, and which is described as a situation where a client can see a method but cannot see the types in the signature of that method, cannot mention the type. This is legal in Java 9, and let me tell you what. Just to allow this kind of situation, increase the complexity at the scale that it cost implementation efforts of several weeks. Not just 2 or 3, several weeks of implementation changes in the compiler. Because of course a compiler has the omnipresent assumption that a qualified name uniquely identifies a type. It's no longer true. We have to distinguish 2 types of the same name and see if it's the right one or not the right one, and even have to continue compiling with that. So if you happen to be in the publishing business and want to write some books, well, no, let's first mention that I'm disappointed about this decision because there was a unique opportunity to make this actually a compile error. And why do I say unique? With OSGI, we have the same situation. We have API tools that would flag this as an API leak. With OSGI, we develop a framework on top of a language. We couldn't change the language. So everything we have to implement in order to find bogus programs has to be done on top. With Java 9, they had the unique opportunity to change language and platform accordingly so that the compiler can already check whether something is a good program or not a good program. This unique opportunity has been missed. But if you're into the publishing business, the good news is that you only have to add a little bit of inheritance. Overloading is always a very spicy ingredient for that, and you will have an infinite supply of Java puzzlers, by which I mean you can write lots of Java programs which nobody will be able to understand on first sight. API leaks make it possible. Overloading helps a lot for this. So summarizing on Act 3, encapsulation, what's the meaning of qualified names? Regarding split packages, they are conditionally legal if they are concealed, by which I mean that no module can see both parts of the split. No promise that it runs. If, on the other hand, you have some use case where you want to have different artifacts contributing to the same package, like for example, if we have a fragment and a fragment host, and they should be actually seen as one and contribute to the same. There's no way this can be made can be implemented with Java 9, even if there's no conflict at the class level. So this is not possible. Regarding API leaks, the Java language specification is totally silent. To tell the full story, compilers do issue warnings, but then compiler vendors should actually coordinate and provide the same warnings. And my efforts trying to coordinate this with Oracle have so far not had much success. Also, reflecting on Act 3 on the state of the specification, and this, so why am I speaking so much about the Java language specification? We have this unique situation. 2 implementations, Java C, ECJ, and 1 specification. And I keep arguing that in this triple, JLS must be the boss. And at the time of Java 8, I've used this picture a lot to explain how you can go full circle from JavaC to specification to the compiler and then compare the result of what both of them do. And if you do this, you have the perfect means of quality assurance, not just for one of the compilers, but for what is Java. Only if the compilers based on the same specification agree, then we can be really sure that we mean the same thing if both of us say Java. Also in bug discussions, if there's any contention about what's the right semantics, I keep putting JLS into the center of the discussion. Regarding JLS version 9, on this stage, let me just go with saying I am concerned in several regards to where JLS is currently and where it's moving. If you catch me at a coffee break or a beer, I can expand on this. At the end of Act 3, we've seen there's a lot of complexity behind. And I mean, this is only the starting point, and the compiler complexity resulting from this is immense. But still, at the surface, the initial picture I showed you should be sufficient for most developers using all this. In Act 4, I will move from complexity to quantity. And if you followed the news during the last year, you may have seen this list of issues. So each of these words was a topic of a highly contentious debate, how Jigsaw should actually be designed. And let me just highlight the one that created the biggest contention: awkward, strong encapsulation. And this is the issue which arises if you happen to have a framework, a library, an application that heavily uses reflection and maybe also uses set accessible, etc., and all these are broken in Java 9. They're broken as soon as reflection tries to cross encapsulation boundaries in ways that are not allowed by module -info. So this was quite a killer, and discussion was strong enough so that Oracle eventually had to say, okay, here's a switch, you can turn all this access checking off completely, permit illegal access, but still this was too tedious because you had to add this command line switch to every application. So they came up with an even better switch. Illegal access can now be fine-tuned to either permit, warn, debug, or deny, and the only way they could get it accepted was to make permit the default. I slowly learned that a lot of the details of Jigsaw are actually not in the language specification but in command line options. And admittedly, quite late in the game, we then started to add a little bit of that also to the UI in Eclipse so that you don't have to learn all those command line options. And here's a project that seems to compile fine in Java 8. So let's go the path and switch the compliance to Java 9. Apply and close. And there are new compile errors. The typical situation, and the first thing we have here is an import can no longer be resolved. Which is because this is an internal class, and well, it may still be there in the JRE, but you don't see the module that contains it. And so the first tweak we may have to do in order to get our application up and running again, and this is important to note, this node is the entrance to all the fine-tuning that I will show now. By this node, we're saying, okay, this entry on the module path is modular. And if you click on edit or double click, the first thing you can see is that the content of all this is now divided into 3 different groups. These are the ones that you are explicitly requesting. These are the ones that you also get because there are dependencies from the top to the bottom. And these are the ones that are physically available in that container, but they are not included in the build. And the selection you see here is actually the specified default for unnamed modules. They only see the right-hand side of this content. And since the type that we need on our applications happens to reside in the module Java activation, all I do is move this to the right, click OK, apply and close. And the bug is that it should not be necessary to clean the project at this point. That bug will be fixed. Wow, I changed the compiler from cannot be resolved to is not accessible. That's an improvement, right? So we know that the type is there, but still we are not allowed to use it because that module doesn't export that package. Second tweak I'm showing you here is that starting from the same path, it already shows that the contents has been modified here. And if you edit and then switch to the details pane, there's several things you can do here. You can say, I'm patching another module or I can add reads edges. For the latter, I don't even have a useful example, but for this one, add exports, we have an example at hand. In this dialog, I'm saying, so I want that package, that the module Java activation should actually export one more package. These are the packages contained in the module, so I choose that constant activation registries is also exported from that module, exported to the current project, and since the current project is not modular yet, the target of this export is the special name all unnamed. So module Java activation exports this package to all unnamed modules. Again, I should not be forced to clean. Wow. Application compiles again. Just to show you one more thing in this dialog about this is modular node. Here is a plain jar. I'm not even using the container, just a jar. And it is currently on the class path. And it says this is not modular. And of course, the older versions of JUnit have not been implemented with a module minus info. But still, Java 9 comes with the option to interpret this thing as a module, which is then called an automatic module. And in order to do so, normally I would just do drag and drop, and we will do that in the future. But this little checkbox at the top of this dialog is our current workaround. If you now click defines one or more modules, then it will automatically jump from class path to module path, and we will see if we can use the jar file name to infer a module name from that, or if it has a manifest with a special attribute by which we can directly control the module name. Okay. These are backup slides in case demo didn't work. Summary. After the 4 acts follows the epilogue. In the last act, I spoke about ways how you can modify encapsulation. People may think this is probably a bad idea. Interestingly, if you search the web for the term gradual encapsulation, you find a paper that I myself wrote many years ago in which I discussed some of these things, starting with encapsulation should be your friend. But there are situations when encapsulation can become your enemy, and encapsulation is the reason you're not able to fulfill your job and to finish your task. And I discuss questions like which decisions should be made by technology, which decisions should be made by people, stakeholders. Who are the stakeholders in a composed application? And I also discuss how much enforcement of encapsulation we need and how much ability for negotiation we need. I'm not going into this now, but my personal feeling is that the way that you have all these options to fine-tune modularity are actually inevitable in the real world. If you want to really have strict encapsulation, it helps you to also be able to define exceptions from the rule. If we go back to Act 3 regarding isolation, do we have achieved the goal of separate namespaces per module? The best I can probably say is we have partly emulated something similar to that. But I'm a little bit disappointed about some opportunities that have been missed there. Regarding Act 2 compatibility, probably read the news that Java 9 is pretty disruptive for frameworks and applications. What I wanted to show you here is that Java 9 is also very disruptive for tool implementers and tools themselves. And so API breakages happen. But still, I want to conclude with something that's more at the level of Act 1. And I have a promise of a feature that will be released very soon. And it is exactly at that level. You will be able to say for an entire module, add non-null by default. I like that. Thanks for your attention. So if people are starving, hungry, you're certainly invited to leave immediately, but I'd also be happy to answer questions if there are any. And
the last slide regarding the annotation, is it already there, or is it coming soon in terms on Java 18 or?
So question whether this annotation is already there or coming in later versions of Java. The possibility to annotate a module is there. Just the interpretation that this particular annotation means that all types and all packages in this module have a non-null by default semantics. This particular interpretation in JDT has not been released yet. And as a side remark, maybe this capability to annotate module files, module descriptors, is the closest you can come to excuse for saying this is Java. Because for those annotations, you have the full sub-language of annotations in Java, and so it is more than a pure manifest. This is the one thing that module-info can do that manifest cannot do, from all that I've seen so far. More questions? Yep.
For me, it seems that basically it's actually not possible to have a more complex application written for Java 8, or have an application which runs both on Java 8 and Java 9 with strict semantics.
So the question is whether it's possible to have an application running on both Java 8 and Java 9 with strict semantics. I mean, every application that runs on Java 9 should probably, if it doesn't use new language features, should probably run on Java 8 as well. I don't make any promise that migration from an existing application is very easy. So I believe the steepest migration path is when you use a lot of reflection, when you use dependency injection frameworks, etc. Some of these things require a lot of either command line options or reworking. Split packages, of course, may require a lot of reworking. I should mention in this context that potentially multi-release jars could be your friends in this situation, which have not been covered in this talk. But I didn't promise it's easy. We're just providing the tools to help you as best as possible. And let me add that we should explicitly solicit much more feedback on the tooling that we have compared to Java 8. We've had quite few bug reports regarding the Java 9 support. And this is what this effort lives from. So if you try it and try to convert your Java 8 applications into Java 9 applications, we may ask you then to download the very newest milestone build, etc. But this feedback, high quality bug reports, is actually one of the biggest assets we have in this community. Okay, enjoy your meal.